First, let's start by writing down the homework, which is going to be 3, 4 odds. We're going to use the rational zero theorem, which is brand new, to find all possible rational zeros. Okay, so make sure you get that homework down. Just the odds. Also, make sure you read what the homework's saying. So, some of them are like really short. You don't have to do a bunch. So make sure you read what it's asking when you do the homework. Okay? So let's go to rational zeros, topic 4. Okay, and we'll recall that a polynomial function of degree n can have at most n real zeros. Like x to the 5th can have at most 5 real zeros. It may have not 5, but that's the maximum. Alright, so far all we've been finding are real zeros. Real zeros can be rational or irrational. And so rational zero theorem obviously only works with rational zeros. Okay, so in other words, rational zeros are those that can be written in the form of a fraction, p over q. Okay, so it only works for those kind of zeros, this theorem that we're going to do next. And these are all real zeros, meaning not imaginary, not with I. We'll get into that later. Okay, so the rational zero theorem can be used to determine all possible rational zeros of a polynomial function. So we're getting back into these polynomials that I cannot factor by grouping. Now that we're in pre-calc, we have to learn other ways to factor a polynomial because we can always factor a polynomial. We just have to figure out what the factors are if it doesn't work in our usual way. Okay, so first way we're going to figure that out is by using this rational zero theorem. So if this function here has an integer coefficients, then every rational zero of the function has the following form: p factors of the constant term a sub 0, and I'll explain what that means, over q factors of the leading coefficient, which is a sub n. Okay, so you don't really have to know what a sub 0 and a sub n mean. We haven't really learned this yet, what that means. This is just a sequence. But constant term, a sub 0, that's your end term. That's your p, okay? So factors of the constant term just means what's added after. So like for 1, it's p is 2. For 2, p is negative 18. So on and so forth. And then the leading coefficient, a sub n, that's your number, the coefficient, in front of the highest exponent. Okay, so the leading coefficient is the number in front of the highest exponent. So like for 1, it would be 1. For 2, q would be 1. Well, yeah, here we go. So 3, q is 4, and 4, q is 3, so on and so forth. Okay? So when we're listing all possible rational zeros, we need to write the factors. Okay? So first we'll write all the factors of p, over all the factors of q, and then each gets a plus minus. Okay, so it could be like plus minus 2, or plus minus 1, or plus minus 3, so on and so forth. So we're just listing all the possible ones. We're not saying yet that those will be factors, but we've got to list all the possibilities, because if you don't, you could have any number ever as a possibility. Okay? As we go on in the chapter, it'll probably make sense why we're doing this. So, for 1, we're going to list the possible factors of p. P is 2. What are its factors? Well, they're 2 and 1. Okay? Then Q's factors, Q is 1. So its only factor is 1. Okay? So all of the possibilities of P over Q, we're going to list those possibilities and then each will get a plus minus. Okay, so I only have 2 possibilities for P over Q. I have 2 over 1 and I have 1 over 1. Okay, so the possible zeros for this are plus minus 2 and plus minus 1. Okay? If that confused you, go through and you'll probably see a pattern once we've done a couple more. Okay, so we're listing out all the factors of P, all the factors of Q, then we're writing P over Q, and we're giving each one a plus minus. Then I just simplified. 2 divided by 1 is 2, 1 divided by 1 is 1. Alright, let's try it again with 2. So if P is 18, negative 18, and Q is 1, we'll list out all of the factors, okay? So the sign really doesn't matter here because we're going to give it a plus minus anyway. So just think of this as breaking up 18. What are the factors of 18? Well, 1 times 18, 2 times 9, sorry, 3 times 6, 4 is not a factor, 5 is not a factor, 6 is, I just said it, 9 is, and 18. Those are all factors of P, of 18. Okay, the only factor of Q is 1. So really, when we do P over Q, our possible zeros, we're going to have 1 over 1, 2 over 1, 3 over 1, 4, 6 over 1, 9 over 1, so on and so forth. So our possible zeros are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 9, plus minus 18. Okay? So we're not sure, we can't factor this function. We don't know how to factor x to the 5th without, well, okay, so some of them we won't know how to factor them. But we have our possible zeros and we will find out how to go from there to find which zero it actually is. Okay? So, I don't want to have to do all of these. Let's do 4 and 6. Okay? And then I'll write the answers for 3 and 5 if you want to try them on your own. Alright, so let's talk about 4. P is 16. We're going to write all those factors out. Q is 3. We'll write all those factors out. Okay? Oh, P equals 16, Q equals 3. Then let's write the factors out. So I'm going to write them low to high, but it actually doesn't really matter. It could be in any order. So 16, 1 is obviously a factor. 2 goes into 16. 3 doesn't, so I'm going to skip it. Then 4 does. And 8 does, and 16. Okay? That's it. Factors of 3 are just 1 and 3. Okay? So what are my possibilities? Well, I'm going to have to rate all of these over 1. So 1 over 1, 2 over 1, 4 over 1, 8 over 1, 16 over 1 with plus minuses. And then I'm also going to have 1 over 3, 2 over 3, 4 over 3, 8 over 3, 16 over 3. All of those with plus minuses. So there's going to be a lot of combinations here of P over Q that are possibilities. Okay? So again, I'm going to match the P of whatever here over 1 first, and then I'll match the P's over 3 for my next possibilities. So how to make plus minus 1, plus minus 2, plus minus 4. Those are all over 1. Okay, so it's just that. But then when I put them over 3, I'll have fractions, okay? So plus minus 1/3, plus minus 2/3, plus minus 4/3, plus minus 8 thirds, and plus minus 16 thirds. Those are all my possible zeros. So one of these or more will be zeros of this function. Okay? Alright, if any reduced, you would need to reduce them, but none of those do there. So we're just going to leave it like that. And let's do 6. Okay? I forgot to say to check that the function is in standard form, because the leading coefficient has to be the number in front of the highest exponent. But for the most part, they should be in standard form already. Alright, so P is 24. We're going to break all those factors up. Yes, there's a lot. And then Q is 2. Luckily, that doesn't have too many. Alright, so 24. I'm going to start from 1, count up to 24, list everything that is a factor, and if it's not, just not include it. Okay, so 1 goes into 24, 2 goes into 24, 3 goes into 24, 4 goes into 24, 5 doesn't, 6 does, 7 doesn't, 8 does, 9 doesn't, 10 doesn't, 11, 12, and then 13, 14, just 24. Okay? So 1, 2, 3, 4, 6, 8, 12, 24. Those are all factors of 24. Then 2 is just 2 and 1. Oh, I should probably write 1 comma 2. Let me fix that. Just to keep it consistent. But obviously it does not matter what order you write these in. Okay, so our possible zeros are going to be plus minus 1 over 1, 2 over 1, 3 over 1, 4 over 1, so on and so forth. And then we'll do them all over 2. Okay? So let's do the ones first. Let me write P over Q's possibilities. Okay, that'll be plus minus 1, 2, 3, 4, plus minus 6, plus minus 8, plus minus 12, plus minus 24. Okay? Now, I'm going to divide each of these by 2 when I write P over Q, so plus minus 1/2. But if something would divide nicely, I'm just not going to write it. Like 2 over 2 is 1, and I already have that. 4 over 2 is 2, and I already have that. 6 over 2, I already have actually a lot of these. So there's only a couple more possibilities. Okay, so that would be plus minus 1 over 2, P over Q, and then 2 over 2, like I said, I already have it. 3 over 2, gotta add that. Okay, and then if I wrote plus minus 4 over 2, I'd have 2, I already have it. These are all even, so I actually already have all of them. Okay? So that means these are all my possible rational zeros. Alright, so once you do P over Q and reduce them, I'll write the answers to 3 and 5. If you want to pause the video right now and try them on your own, you can. If you think you got it, totally fine, don't worry about it. Oops. Alright, so the answer to 3 will be plus minus 1, plus minus 2, plus minus 4 once you reduce all of them. Then 5 has a lot. Plus minus 1, plus minus 2, plus minus 3, plus minus 4, plus minus 6, plus minus 12, plus minus 1/6, plus minus 1/3, plus minus 1/2, plus minus 2/3, plus minus 4/3, plus minus 3/2. I think that's all. Okay? Alright, so let's go to the next page. Actually finding the rational zeros. Okay, so once we have listed all possible zeros, we have to test the zeros using synthetic substitution. Well, what does that mean? How would I know it's a zero? Well, if I synthetically divide and I get a remainder of 0, whoops, then it's a factor. That came from our factor theorem. We just did that. So, meaning I get a remainder of 0. That is a factor. Okay? when you find a zero that works. Use the remainder to completely factor the polynomial, then find the zeros. So we're not going to do all of these, okay? We're just going to do a couple until you get the point. So number 7. Again, if I tried to factor by grouping, there's no way I'd be able to do that. So that's why we're doing the rational zero theorem. Okay? P is going to be -8, and Q is 1. Okay? So, oh, sorry, P is 8. The sign doesn't matter. Q is 1. Alright, so my possibilities of 8 are, my factors are 1, 2, 4, and 8. And then Q is just 1. So my possible rational zeros, P over Q, is just going to be plus minus 1, plus minus 2, plus minus 4, plus minus 8. Okay? Those are my possibilities. So what I have to do from here is pick one of these, plug it in, see what remainder I get, and if it's 0, then I'm going to factor it and find the zeros. This is a super long section, but stay with me, okay? So my possibilities are 1 and then -1. Let's go ahead and synthetically divide 1 and see what happens. So I'm going to synthetically divide this polynomial here. And I start with 1. If it's not 1, I'm going to try -1. If it's not that, I'm going to try 2, then -2, then 4, then -4. So, it takes a bit. Okay? So, my coefficients here are 1, 3, -6, and -8. Let's synthetically divide. So I'll bring, hold on, I'm going to need some more room. These take a bit, so. Okay, let's bring the 1 down. 1 times 1 is 1, 3 plus 1 is 4. 4 times 1 is 4, -6 plus 4 is -2. -2 times 1 is -2, and I get a remainder of -10. Okay, so all that means is, whoop, that's not a 0. So unfortunately, we have to go and try the next one. Okay, and I'm going to help you out with a couple of these, but the next one I want to try is -1. Okay, so let's do that and see what we get for the remainder. Okay, so I have 1, 3, -6, -8. So I'm going to bring down the 1. 1 times -1 is -1. 3 minus 1 is 2. 2 times -1 is -2. -6 minus 2 is -8. -8 times 1 is 8. Remainder 0. Okay, so I know -1 is a factor. Woo! Alright, what's left is x squared plus 2x minus 8. So we're going to have to factor that and find the rest of the zeros. X squared plus 2x minus 8. Find those zeros. Okay, so that would be x 4 and 2. So plus 4 and x minus 2. Okay, so my other zeros are -4 and 2. So what are my actual zeros? -4, 2, and then -1. Okay, so I know that these came out super nice. 4, 2, -1. But we couldn't factor it from the beginning. We couldn't find a common factor that would work there. Okay? Alright. Let's skip to 10. And then I'll write the answers for 8 and 9. There's a ton of examples here. So hopefully by 10 you'll get it. Okay? So also what I want to point out is if your neighbor decided to try a random one and they actually tried -4 first, they would get a remainder 0. They'd have a different polynomial to factor, and they would still get the same zeros. So it doesn't matter which one you try. Okay? You're going to get the same answer at the end, if you did it right, of course. Okay, so 10. Let's move on to 10. We're going to find the possible rational zeros. P is 6, Q is 2. So let's list all the possible rational zeros. I'll do it on the side here since I have some room. So P is 6. That means 1, 2, 3, 6. Q is 2. That means 1, 2. So we're going to have some fractions here. Okay, so my possibilities, which are P over Q, are plus minus 1 over 1, 1, plus minus 2, plus minus 3, plus minus 6, and then we're going to put them all over 2, so plus minus 1 half, plus minus 2 over 2, that's already there, that's 1, and plus minus 3 halves, and then 6 over 2 would be plus minus 3, that's already listed, so that's it. Whew, okay. So, just to point out, we can't synthetically divide 1 half and 3 halves. We can't do that. So, we're going to have to pick 1, 2, 3, or 6, the positive or negative. Divide all that. Oh, goodness gracious. And then, we'll find our answer, okay? So, just because I've done this, and this takes a lot of time just guessing, we're going to try 2. Okay, so let's plug in 2. Bless you. My dog just sneezed. Alright, so let's try 2. Okay, we're going to synthetically divide. So my coefficients will be 2, negative 5, negative 1, 6, 3, 2, 1, 0. Okay, cool. So let's plug in 2. If I didn't pick 2, I picked like negative 2 and it didn't work, I would not get a nice remainder and I would have to pick another one. So these take a long time. Alright, so 2 times 2 is 4. Negative 5 plus 4 is negative 1. Negative 1 times 2 is negative 2. Negative 1 minus 2 is negative 3. Negative 3 times 2 is negative 6. Remainder 0. Okay, so I'm good. This gives me 2x squared minus x minus 3. Okay, so I found 1, 0. I gotta factor the other polynomial to find the other 2. So let's see where that equals 0. Alright, this will be slide and divide. 2 times 3 will give me x squared minus x minus 6. And I'm going to factor it. X. Oh, this one's always tricky. Okay, 1 will be minus 3. And plus 2. Yep, okay. And then we're going to divide the 2. So we slid the 2 back, got to divide it. And now you can see your other possible zeros are showing up, right? This will be 2x minus 3 times x plus 1. Okay. So my zeros are x equals 3 halves, x equals 1, negative 1, sorry. And then we found 2 from using all the theorems, from using the rational theorem, then from using the factor theorem and the remainder theorem. Okay, and last thing I just want to point out is that, hello, these should be some of your zeros you found here. They should all be listed, okay? And they all are. Alright, that's it. You have just the evens to do for homework. I'll rate the answers to 8 and 9, but you can stop the video now if you want. And then, so if you're still playing it, I would maybe just get with a partner and try to split them up, okay? It's gonna be a lot of work if you try every single possibility. Okay, so that's the answer to 8 and 9. If you want to try those before you begin. Don't worry about the next page. Okay, that's it.